I can approximate and interpret a function's average rate of change over a specified interval given the graph of the function. We need to know. The average rate of change is the change in the y value divided by the change in the x value for two distinct points on the graph. Remember that this will be on your EOC formula sheet, written just as you see it. And what that means, the change in y values is really when we subtract the two. So it would look like y2 minus y1, and then it says it's divided by, so I would divide by my x's, the change in them. So x2 minus x1. This is what we're going to be using when we go to find our actual change. Now, linear functions, they have the same rate of change, okay? They have a constant slope throughout their function, but exponential and quadratic functions, their rates of change, they differ depending on what points we're looking at. So we call it the average rate of change because we're just looking at a specified interval. It doesn't have a constant rate throughout the entire function. So like right here, the exponential function g of x, that's this blue function here, it has a rate of change of 0.5 between the green points, but then the blue points up here, it has a rate of change of 2. Okay, so this is a greater rate of change here than we had right here. Right here we had 0.5, and then up here we had a rate of change of 2. So we're going to go ahead and look to see how we can find those values from a graph. So in this case, it says the graph shows the value of a car at different years after purchase. We want to know what is the best estimate for the average rate of change between year 10 and year 12. So here are my two x values because my years are on the x-axis. So I could say this is like my x1 and this is my x2. And I need to figure out the y values for each of those. Well, year 10, we can see here, it's partly been identified for us, is going to be at 10, 10,000. And then year 12 is already written out for me here, 12, 7,000. So this is my x1 and my y1. This is my x2 and my y2. And again, we want to use our average rate of change formula. So that's my y2 minus y1, the change in y's divided by the change in x's. So we're just going to plug in our values. My y2 was 7,000. My y1 was 10,000. And we divide that by my x changes, so 12 minus 10. So 7,000 minus 10,000 is negative 3,000, and 12 minus 10 is just 2. When I divide these two, I get 1,500. So what does that mean for this situation? Well, this is talking about the value of a car after different years. So from year 10 to year 12, my value has decreased by $1,500. So the value of the car decreased by $1,500 per year. So each year between those two values, I was losing about $1,500 in the value of the vehicle. Let's try another one. Same context, same situation, but we're going to look at two different values in terms of the years. So now would be a great time for you to pause and try this one on your own to come back and check. So this time we want the best estimate for years 0 to year 10. So again, I'm using y2 minus y1 over x2 minus x1, but this time I'm using year 0 and year 10. Okay, and remember year 10 was at 10, 10,000. So my y2 value, that's going to be that 10,000. And I subtract that from my y value when I first got the car. So when I first got the car, I paid $25,000 for it. And then I subtract my years, so year 10 minus year 0. So if I take 10,000 and I subtract 25,000, I get negative 15,000. And then we're going to divide that answer by 10. And when I do, I'm going to end up with negative 1,500 again. So this is a unique situation where my average rate of change happened to be the same between two different intervals. So that can happen, but a lot of times you'll get two separate answers. So the average rate of change is telling us the same time. Again, the car is losing value at $1,500 per year between okay, so we're losing $1,500, or it's $1,500 less each year. That's what the value is. The value, I should write this in a sentence, value is $1,500 less each year than it was the previous year. So again, most of the time you're not going to get the same answer. In this case, we did. A little bit more information on this topic and applying the formula for average rate of change, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.